Welcome everyone. Today we're going to present our project about a V6 engine. In this presentation we will walk through the design, analysis and key components of the engine. This presentation is presented to Dr. Ayman Abbas. This presentation is also presented by Hamza Al-Asi, Ibrahim Ahmed and Ahmed Sharif. First thing I'd like to talk about is the idea development. The idea of our V6 engine project was developed to understand how a multi-cylinder engine works as a complete system. We chose the V6 configuration because it offers a good balance between performance and compact design. First, we studied the main engine components such as the piston, crankshaft, cylinder head and the valves. Then we divided the engine into sub-assemblies to simplify the design and analysis process. Each part was modeled in SolidWorks with appropriate materials based on strength and thermal properties. After modeling, we performed thermal and stress analysis on critical components like the piston and cylinder head. We also conducted a sustainability study to evaluate environmental impact. Finally, all parts were assembled and motion study and exploded views were created to demonstrate the engine operation. Then, I'd like to describe the description of a V6 engine. Our project focuses on designing and analyzing a V6 internal combustion engine using SolidWorks. The V6 engine consists of 6 cylinders arranged in 2 banks, which provides smooth operation and balanced performance. The project includes modeling all main components such as the engine block, piston, crankshaft, cylinder head, valves, and exhaust manifold. Each part was designed with realistic dimensions and assembled into a complete engine system. The project also involves performing simulations including thermal analysis and stress analysis to evaluate the performance of critical components under operating conditions. In addition, a sustainability study was conducted to assess material efficiency and environmental impact. And now for the function of the project. Our V6 engine project is designed to convert fuel energy into mechanical power efficiently. It demonstrates how different engine components work together to produce motion and performance. Well, here is the stress analysis of the cylinder head. The image shows a static stress analysis of a cylinder component performed in SolidWorks, and the deformation scale is set to 0, suggesting no visible deformation under the applied conditions. Well, here is the camshaft. This image shows a static stress analysis of a camshaft model, and the deformation scale factor is applied, exaggerating the shape to make the stress-induced deformation more visible. Well, here is the rocker arm. This image shows a finite element analysis of a rocker arm component. Most of the component remains in lower stress regions, suggesting only localized areas are critically loaded. Well, here is the crankshaft. This image shows a finite element analysis of a crankshaft model. The deformation is exaggerated to make structural behavior under load easier to visualize. And now for the engine block. This plot shows the total displacement of the engine block under applied loads. The maximum displacement occurs in the less constrained areas, while fixed regions show nearly zero movement. And now for the valve. This plot shows the total displacement of the valve under applied loads. The deformation is relatively small, indicating that the structure is stiff and stable. And now for the stress analysis for the piston. This plot illustrates the VMS distribution on the piston under applied loads. The stress values are significantly below the material yield strength, indicating a safe and reliable design. Here is the picture of the visualization of the V6 engine. And now for the project evaluation. This project demonstrates the successful design and assembly of a V6 turbocharged engine using SolidWorks, highlighting key principles of mechanical design, component integration, and motion simulation. Throughout this project, challenges such as component alignment, dimensional accuracy, and realistic assembly constraints were addressed. The final model reflects both functional understanding and attention to engineering detail.